Hey guys, welcome to our webinar with the title, The Development of MedTech Project During Studying at the University. My name is Irina and I'm a communications officer at Al-Fihri Open University, and I'll be your mediator today. So here we are with our speaker, Vladislav Kostarev. He's a 21-year-old engineer programmer based in Russia. From his school years, he was interested in socio-technical projects and participated in numerous conferences, business accelerators, and in his hometown. At the end of his school education, he came up with the idea of developing a trainer for rehabilitation after stroke or limb injury. And at the university, he managed to assemble a team of students who helped him to develop a working prototype and won a competition of the project activity subject in the university. With COVID-19 strikes, Vladislav transformed his project to system of the distant rehabilitation after stroke or limb injury, and that later became his end thesis. Just to add, if any of you have questions for Vladislav, write them down in the comment section and he will answer them in the end. So, hi Vladislav, how are you? Can you tell us a little bit more about yourself and start talking about the development of the MedTech project you're studying at the university, please? And welcome again.
Yeah, thank you, Irina. Good day, everyone. My name is Vladislav. I graduated from Peter the Great St. Petersburg Polytechnic University. And in today's online lecture, I'd like to tell you about my process of development of my own MedTech project. So first things first, I won't be talking much about entrepreneurship stuff and how to grow up your project into successful startup, because I'm more an engineer person, and of course it's also important part of project entrepreneurship, yeah, but I think I should give you information that I'm more confident about as a graduate programmer. So, how it began? The idea of development a robotic device for rehabilitation of arm after stroke or limb injury came to me in high school. I was really passionate about robotics, and once my school teacher offered me to participate in robotic conference competition in my city, where you should design a project using a Lego construction kit. As a kid in this age, as any kid at this age, I dreamt about superpowers or something like that. So I decided to develop an arm exoskeleton. Yeah, and after 3 months of development, I built my exoskeleton. It covered the whole hand, and it had 2 DC motors that helped to bend the arm at the elbow. Also, there was another motor near the wrist, which helped to do the palm grip movement. And controlling of the skeleton was quite unusual. I created a helmet with the 2 color recognition sensors. When you raise your left eyebrow, the skeleton bended the arm, and when you raised your left eyebrow, the skeleton straightened up the arm because the sensors could track difference between your skin color and your eyebrow color. Also, if you raise up your both of your brows, exoskeleton made a palm grip movement. So it was really fun project for me, and after winning several city competitions and participating in exhibitions, I met a professor from State University of my city, and he said that it would be better if I use my exoskeleton as a passive arm training device for people who are recovering from a stroke, after a stroke. And I was really inspired by that idea that because it was just a big opportunity for me to help other people. So with that idea, I entered the seed accelerator of Cities State University, where I learned how to build business models for your own project, and how to just bring a new technology to business, put new technology to business. So also there are many healthcare professionals and therapists in the discussions, with whom I decided to upgrade my project by adding electromiography sensors to perform active trainings and track the dynamics of rehabilitation. So let me explain what is electromiography, or EMG, is. EMG sensors are the devices which allow you to track muscular activity, and it consists of 3 sticky electrodes that should be attached to the muscle, one to the start of the muscle, one to the end of the muscle, and one to the bone. It's very useful technology. But the most important part of that I discovered in the communication with therapists is that some of patients might have spasticity or contracture, which means constraint of the movement range due to muscular spasms. With that vast amount of medical information that I received, I decided to focus on combining passive kinesiotherapy. It's when the training device performs the movement for the patient. So the patient has nothing to do. Sorry. And active kinesiotherapy, when the patient tries to perform the movement by himself. So EMG sensor detects his effort, that he's trying to bend his arm, and the training device helps him to complete the movement. This time, as a controller, I designed an Android mobile app for the therapist, of course, which sent commands to trainer via MQTT protocol. Yeah, this lecture will be more for engineer kind of people, but let me explain it. What is this protocol is, and that means it can be sent, the program can be sent from the phone via mobile network, via the internet, and it could be received by the trainer anywhere in the world if it's connected to the Wi-Fi. Yeah, and mobile app allowed a therapist to set the number of repetitions, flexions and extensions, and also the therapist can set limits of the movement, like from angle and to angle, and also you can set speed in order to prevent spasticity. The trainer itself also changed the frame of trainer. The first, it was made of thick copper wire as a skeleton, and polymorph plastic, which becomes soft at the boiling point of water, and therefore it's ideal for a prototyping in condition of a limited budget. A linear actuator motor was used to bend the arm. The angle was controlled using the encoder at the bend point, and finally, the brain of the trainer. Instead of Lega controlling block, I used Arduino Uno microcontroller, which perhaps some of you are familiar with. There were also models in the scheme. There was a DC model driver model and the ESP 8266, which helped to implement the interaction via MQ2 protocol. The training device was powered by the batteries, so you can carry it out of your home and go training everywhere you want. As a result of acceleration program, I won a prize and received a small amount of funding, which recouped the cost of the prototype. It was around $300. So later, I entered Peter the Great St. Petersburg Polytechnic University as a programmer. And I decided to continue the development of this project and at the second year of during the project activity subject contest, the second year of my study, I used my own project to participate in this contest. As a part of the competition, I assembled a team that consisted of a hardware developer for creating an electrical circuit, software developer for establishing interaction between the trainer and the touch screen. I'll explain later. And user interface designer, and design engineer to create a strong frame, strong skeleton of trainer, and project manager, and of course medical consultant. First of all, we presented my existing solution, my existing project to study department of computer science and technology in the university, and after which they granted us financial help in amount of $200 for a new prototype development. Also, following an advice of a study department, we came to the biggest hospital in the St. Petersburg and showed our project to rehabilitation therapists to gain feedback. They were impressed, but they say that it's not so convenient to control patients' training devices via smartphone, as it was made previous. Because there is no need in remote control when a patient and the doctor are both in a hospital in the same building, you know. Also, therapists mentioned that the frame of a training device looked fragile and unappealing. A big, yeah, of course it was, because it was a prototype made of scrap and the plastic, the wire. Yeah, and the big discovery for us was the concept of BFB for biofeedback technology, which states that rehabilitation is going better if the patient has the opportunity to track his progress by audio or visual representation. So from that point, we decided to build a new prototype that would be controlled with a touch-sensitive display, as I mentioned previously, and would have a brand new, strong and well-designed frame. In this version of the prototype, we focused on the stationary of the device and biofeedback with the patient. So to achieve stationarity, we assembled all the electronics in a small box with a touch screen and put it on a rack. Also, batteries were replaced with a consistent power source because they were just reducent. And to achieve biofeedback, we decided to use a sound reproduction model that voiced the patient's movement, encouraging him when he needed to make a movement on his own.
I'm sorry. Sorry to interrupt you, but there was a comment in the comment section that you are speaking very fastly and well, with a lot of medical information. Could you please slow down a little bit so that everyone can understand? Yeah.
Oh, I'm sorry. Yeah, of course. Yeah.
Sorry for interrupting.
No, it's okay. Yeah, I hope you understand what is via feedback. Okay, I'll try to be slower. So to achieve via feedback, we decided to use, yeah, I already said that. Sound reproduction model, yeah, that voiced the patient's movement. Then we implemented an encouraging element of gamification by making difficulty levels in active training, in active kinesiotherapy, and adding the patient's effort bar to show how much strain, how much show to him what muscle strain he has achieved. Yeah, and now the trainer contained both prepared programs and advancing constructor of trainings, which allowed the therapist to combine several exercises in one single training program. It's just simple not to set every exercise separately. You just put all exercises in one training and just start it and go away. So a little more about hardware changes. Arduino was replaced with ESP32 microcontroller because it could be connected with more models and supported Bluetooth and Wi-Fi natively, which could be useful in the future. Actually, it will be useful, you'll see soon. So after winning project activity subject contest, the SPB-STU, my university, SPB-STU innovative development department became interested in our project, but I decided not to go into entrepreneurship because I wanted to grow up as a specialist in engineering. Yeah. Later, coronavirus infection, stroke when I was in my last year of studying, and hospitals were full of people with pneumonia, while patients with other health problems like stroke or limb injuries were forced to wait or were dismissed from the hospitals, not fully recovered. I could not overlook this problem and came up with the idea of creating a system of the distant rehabilitation after stroke or limb injury, which would allow a patient to undergo rehabilitation at home while a doctor will receive feedback after the patient performs the specified exercises and adjust the rehabilitation program remotely. This approach is called telerehabilitation, telehealth or e-health in the Europe. This means distribution of health-related service and information via electronic information and telecommunicational technologies. The telehealth allows long-distance patient and clinical to contact care, advice, reminders, education, and remote admissions, and a lot more. With that approach, the patient just needs to visit the doctor only one time to prescribe restrictions and develop an individual rehabilitation plan. and select a trainer device according to the size of his limb. Yeah, so I decided to take this project as my final thesis. And as a base, I used my stationary prototype that I created earlier. So a website was created for the doctor with the help of which he can monitor the dynamics of the rehabilitation of his patients and send them new training programs. A mobile application was created for the patient, which checks if there a training program available for a patient that they didn't perform earlier. And if they are available programs, then the training program is transmitted to the training device using the Bluetooth Low Energy protocol. And after the training is complete, the training device sends a report back to the phone, and the phone transmits it to the server in the doctor's personal page account. The server and the doctor personal page were developed with a Python and the Flask framework. As a database, the PostgreSQL was chosen, and the mobile application was created with written in Kotlin. And if someone wants to see the code of my project, I can send a link to my GitHub, link down. You can say that in comment below. Yeah, so now after defending my thesis for the highest assessment, I'm looking for an internship in medical companies that develop equipment for rehabilitation. At the same time, I make minor corrections like bug fixing in my rehabilitation system. And I'm planning to apply for a seed accelerator again in order to finally bring the project to a new level. To be honest, when I prepared this lecture, my main goal was to show that it's not so difficult as it seems to create your own MedTech project. If you're a programmer or engineer, want to help people and improve their life conditions, but you are afraid of that you don't have enough medical knowledge to realize your project, you should just find a person, a doctor, a therapist, and describe your idea to them. It's the fastest way to understand if you are going in the right direction. And if you are not a programmer or an engineer, but you have a project, idea of project, which theoretically can save someone's life, just tell about it to the programmer or a doctor. They may support your idea. It is the most important is just to speak and to try. Who knows, maybe your idea can be a beginning of a breakthrough in the MedTech. So that's it, I think. If you have any questions, I can answer them. Thank you.
Thank you, Vladislav, for so interesting and full of interesting information lecture. I think it was useful for a lot of people. And yes, I have some questions for you. So first of all, what is your advice to anyone willing to start a MedTech project?
First of all, you need to, you have to understand if you want to develop a project on your own as a specialist or to gather up a team and be a leader. If you need to help from more experienced people, then you'll just try to figure out which science labs in your university can provide that knowledge to you. Some laboratories can do both medical and engineering projects. If that's so, it's perfect. So just rush there and explain your idea to them. And maybe your idea will, maybe they can provide your specialist and give you a funding or something like that. It's just a good idea to tell them. So if you plan to create a startup based on your project, then you look for seed accelerators, I think. They can be in your university also. As a rule, such programs are focused on the business part of the development of a project. You can gather a team during pitch sessions by stating that you're looking. And for a mobile development, you are looking for a mobile development. You want to develop a mobile app that helps people to track medical drugs date, for example. And you're just can come there with your idea and ask for help. Just state your idea. So also you can go to the centers of additional education, such as co-workings and hackathons, maybe, where people with different skills but with common interests are meeting. That's exactly what you're looking for. You're looking for interested people with someone who can help you with your idea. If you are nevertheless willing to develop your own with a project on your own, you're lacking of skills for building that project of your MedTech in the MedTech sphere. You can try to put it into practice by realizing small parts of it in the creative assessments, like courseworks and the end thesis, for example, and just find interesting subjects that can be helpful for you and in your study program, and try to convince your teachers. They often support initiative students. So what you need to do, it's simply divide your idea into small components and understand which subject can be helped to realize which part of it, your idea. In that way, you will build your project. You will build your minimum viable product, which can help you to attract partners or gather a team in the future. So nothing came in my mind. I think that's it.
Yeah, thank you. Okay, so you told us that there are two options. You can either look for a team or and for the help, or you can do it on your own. And what do you think works the best?
I think it's a more personal question. In my opinion, as an engineer and professional of tech side of project, I think it's better to realize your project on your own if you want to develop some skills in programming or electronics, for example. But if you want to, if your main idea to build a successful startup, then you absolutely need a team. I was not so interested in building startup. I think so because it's more interesting for me to develop than to be a leader. And yeah, and it depends on your purposes. Yeah, but if you want to, either of them can lead you to success. I think so, but differently.
Okay, thank you. Well, thank you again very much, Vladislav, for your time and your valuable talk and answering our questions. And thanks everyone for watching this. So have a good day and good luck in your future career steps. And thank you again, Vladislav. We wish you a great success with your future projects. Thank you for coming.
Yeah, all the best. Bye.